Hello, I'm Charles Rice, and this is
Shumail Gilani.
And we're two cloud solution architects in the customer success unit for Microsoft Education. We truly see our customer success as Microsoft's success. In order to achieve that, our goal is to create real value for our customers by using our products. What we mean is create value across the institution, from a very high level to faculty, staff, research, and last but not least, students.
I would say more than that, Charles, because if you see the customer nurturing cycle here, we start with engaging with the customers, transacting with them on each and every phase of their progress, and actually helping them in the adoption of the Microsoft Cloud much easier, much simpler, and a customer keeps getting the growth cycle increase every time we repeat this cycle.
Data science and research analytics are two really hot topics right now, especially in Azure. And what we've done to make sure that you're ready to go to start conducting that research in data science in Azure is we've created training videos, case studies, labs, hackathons, templates, and much more.
So stay tuned, there's lots of more fun coming on these areas. Myself, Charles, and my team are creating lots of material here. So keep watching, keep providing the feedback to improve all this content. Thank you very much for joining.
Thank you.
Hello, good morning, good afternoon, good evening, wherever you are. Welcome to our fourth video in Azure for Data Science series. Myself, Shumail Gilani, and here is
Charles Rice.
We both are cloud solution architect from Microsoft US Education team. We belong to customer success unit. We are super excited because we have two very brilliant students from UT Austin, Texas. Instead of me introducing them, let them introduce it.
Thanks, Shumail. So, hi everyone, I'm Kirti and I'm currently doing my Master's in Business Analytics from UT Austin. So, both me and Thiru, we both are really passionate about data science, and we'll be walking you through one of a very interesting data science project on Azure. And the one for today is carrying out sentiment analysis using Keras.
Hi guys, I'm Thiru and also a graduate student at UT Austin. I'm studying business analytics, and today we're going to be doing sentiment analysis using neural networks and Keras on Azure notebooks. It's a really cool project and it'll blow your mind, so let's get started.
All right, cool.
So now we've already been through how to build a project and then a new notebook in that. So today we'll just go through the sentiment analysis file that we already have built. Before I start, what I want to talk to you guys about is what is Keras. So Keras is essentially an open source Python library which is built on top of existing deep learning frameworks. So you can use either TensorFlow, Theranov, or CNTK. Today we'll be using TensorFlow. Now, building even a small neural network is very complicated, and it takes like huge chunks of code to start off with. So Keras helps us reduce the size of code and makes building even complicated neural networks in just a few dozen lines. So it's a really cool library, and let's get started.
So you could basically think of it as an abstraction layer for creating.
Yes. It's like an API built on top of
Awesome.
other frameworks.
Cool.
So today for sentiment analysis, what the data set that we're going to be using is the IMDb movie review data set. It's already built in Keras, so you can just import it from keras.datasets, as we can see in the first cell. So what this piece of code is doing is not only loading the dataset from Keras, but also splitting it into a train dataset and a test dataset. So we will be using the train dataset to essentially train our neural network, and we use the test dataset to kind of see how our neural network is doing. Now, speaking a little bit more about the dataset, first of all, this is how one row looks like in the dataset. Now, what this essentially is...
So one row is one review?
Yes.
Okay.
One row is one review, and what each of these integers that you see are essentially words. So each word in this dataset has been given a unique word ID, and this is the integer that you see here. And the lower the integer, so for example, if the value that we see here, 4, that means it's like one of the highest occurring words in the dataset. If you want to learn more on how this dataset has been processed and what all it entails, you can take a look at the Microsoft Learn website where more information has been given. Also, if you're curious about what all of these integers mean, you can just run this line of code, which gives you the dictionary or which has the word as well as the word ID. Now we want to look at, if you want to look at what the review is. We just saw integers and numbers, but you want to see what the actual review was. You just run this piece of code, and you can see this is a review about a movie, which was the first or the third row in our data set.
Okay, so it's just concatenating all the words together.
Yes,
okay.
It's building all of them, getting what the integer is corresponding to which word in the dictionary, and just giving you concatenated.
Putting it all back together.
Yes,
yeah.
putting it all
okay. So a human can read it instead of a machine.
Yes. So now we've got a good idea about our data set. Let's switch over to Kirti.
Yeah, thanks, Thiru. So now after looking at what our data set is about and what we are actually doing, let us get into the neural networks part of it. So before we start, we need to actually treat our input. So our input is like a set of reviews, and each review is of varying length. Some reviews are short, some reviews are long. So what we need to do is bring them or make them of consistent sizes. So we have taken the maximum review length of 500, and by utilizing a function called pad sequences, which is offered by Keras, we are converting all our reviews to a length of 500. And that's what we do in this step. So I'm running the code. Our training data set and our testing data set is ready. And
I guess it's safe to assume if you're trying to get sentiment from a review, 500 words is enough to find out whether someone's upset or happy?
Yeah.
Okay.
That's what we're keeping it to, just to be consistent.
And I
Sure,
also
that makes
feel
sense.
like 500 is a good amount of words for a movie review, so that's also factored.
Absolutely.
Yeah. Okay, so now we'll be building our neural net, and before we build it, I'll just run the code. And this is the neural network that we have built. So if you look at the code, it's initially the model is equal to sequential. Now a sequential model means that the layers are stacked one by one next to another, and that entire neural network comprises of the embedding layer, a flattened layer, followed by 3 dense layers. So the embedding layer is the most important layer in this neural network because we are dealing with text. And if you want to know more about how an embedding layer works and what it's all about, you can check out the website which Steve spoke about. Next, since the output of an embedding layer is generally a 2D matrix and we want to feed in a 1D matrix to the dense layers, we utilize a flattened layer which will flatten the 2D matrix into a 1D matrix. And here we have 3 dense layers, and out of which the first 2 utilize the ReLU activation function, and the final one uses a sigmoid activation function because we want to generate a sentiment score between the values of 0 and 1. For this entire model, we'll be utilizing the binary cross entropy loss function and the Adam optimizer, and our metrics would be the accuracy. So this is our model. It's pretty short, but if you want to learn a bigger or deeper neural network, you can always do that using Azure's GPU computing resources. And
Right, because this is running on free compute right now,
Exactly.
so it's not costing anything. It's small algorithm, small neural network, so it's more than enough horsepower.
Exactly. So Azure is there to take your back. Then so now when we want to fit our model, we run the model.fit, where we are passing our training data and our validation data, as well as epochs and batch sizes. So on running this, it is training now. It's fitting now. So what do the epochs and batch sizes mean? Now epochs means the number of times the model is trained forward and backward, and the batch size means the number of training samples which are taken to train the model. And you need to strike the right balance between the epochs and the batch sizes in order to get a better accuracy, as well as avoid overfitting. And keep in mind the number of resources you have, because if you have a very small batch size, then you may require more number of computational resources.
Okay, so for each incremental epoch, it's going from more and more accurate, from 64% to 3 nines of accuracy.
Exactly.
Right?
So you can see that as the epochs are increasing, your accuracy is increasing as well. Now let us test it out with a smaller batch size, and we are predicting that we'll obtain a much better accuracy by doing so. Looking at the accuracy, you can see that a 19.999 accuracy and like it's really high for a training data set. So that sounds slightly fishy. So I think it may be something to do with overfitting. What do you think?
Yeah, definitely. We should check it out.
So on checking it out, let's just run this code. And this is the graph we obtain when we plot our training loss and our validation loss. We can clearly see that after the second epoch, the both of them start diverging, and from the third epoch, they diverge like massively. So you can clearly see that this is definitely a sign of overfitting because your training loss is minute, but your validation loss starts increasing.
So what that's saying is that after the third epoch, each additional iteration isn't impacting it as much? Is that what it means by training loss? It's not adding to the training it's already had? Is that correct?
It is adding more to the training on the training set.
Okay.
So it's getting very adjusted or
it knows the data.
it knows the data too well,
Yeah,
the training data.
Sure.
So it's fitting to the nitty-gritties of the data in
Yeah.
the training data set, but it's not generalizing.
Got it.
Yeah,
Nitty-gritties.
and that's what we want.
Because it's the only data it's had, right? So
Yes.
Yeah, sure.
So now when we look at our accuracy, you can see that it's an 84.31%, which is
Now we're
bad.
instead of looking at it against trading data, we're looking at test data.
We're looking
right?
at
So
test data.
We went
Yes.
from 99.95 to 84.
84.31%.
More
And which is
realistic.
actually pretty good because by building such a small neural network and without any GPU computational resources and making it so faster and simpler, getting an accuracy of 84.31, that's pretty good.
Yeah.
So now let's move ahead and although we know that this model is overfitting, let's just see how our results look like. Probably when we run our model again, we can try a smaller number of epochs, and if you guys try it out, do let us know in the comments below. So now let's build a function, analyze, where we can pass the review and we can probably get the sentiment out of it. So over here we are just dealing with the input we are provided, and then we are going to predict it using the model we just ran. So now on testing it, we have two sentiments which we'd like to test. The first one being easily the most stellar experience I've ever had. So if you had to predict, what do you think the sentiment would be like?
Should be pretty positive.
Overwhelming.
Overwhelmingly positive, right? So on running that, yeah,
100%.
it's
Pretty
almost
much,
100%, yeah. And then something like the long lines and poor customer service really turned me off.
Turns me off
Pretty
now.
negative, right?
Yeah.
Poor sentiment.
And that's almost a zero.
Almost zero.
Doing pretty
Incredible.
good.
That's
Yeah.
awesome.
Wow, amazing. The most exciting part here is that what a complex scenario it is.
Yes.
How simply and quickly you can run.
Not only simple and quickly, but also this was all free too. This is running free
Oh,
compute, right? So like
That's
she said,
amazing.
this is a small data set, more free compute's more than enough power to
And this is all free.
something.
right?
I mean, this is a powerful tool. Right
Wow.
now, right? So
Wow. Thank you very much, Kirti. Thank you very much, David. I don't know how to say thanks, but thank you very much. Thanks for joining. Watch for more videos. They are upcoming, and I think Charles has
Yep.
some plans.
all right, so yeah, this was our fourth video in Azure and data science using Azure notebooks. And what we have planned for the future very soon is doing health and research analytics in Azure as well. So stay tuned.
Artificial intelligence is fueling the next wave of transformative innovations that will change the world. With Azure AI, our goal is to empower organizations to apply AI across the spectrum of their business.
We are developing the tools to enable anyone, not just PhDs or researchers, to harness the most powerful AI supercomputers in the world in order to overcome their problems, no matter how complex.
We are moving beyond big data and machine learning capabilities to be able to infuse cognitive capabilities.
I think Azure for research with the cognitive services and the machine learning capabilities there are phenomenal to help researchers actually maximize their time. They spend less time building and maintaining systems and more time actually implementing and doing the studies that are necessary for this research.